How does the monitor work? Signals from your computer's video card are loaded into 3 electron guns at the base of the monitor. There is one gun for each of 3 colors: red, blue, and green. These 3 colors, when mixed together, can create all the colors you see on your screen. Now, these guns don't shoot bullets. Instead, they shoot a powerful beam of electrons towards the face of the monitor. The beams pass through the deflection yoke. It uses magnetism to bend the electronic beams so they can sweep across the entire screen and create the picture we see.
What happens once the beams have swept your monitor? Special chemical phosphors are painted on the inside of the monitor. Energy from the electron beams makes the individual phosphors glow either red, blue, or green, depending on the type of phosphor. The stronger the electron beam, the brighter the phosphors glow. A sheet of metal with holes in it helps keep the electron beams aligned exactly with the phosphors. This is called a shadow mask. The beams sweep across the entire screen 60 times per second. It happens so quickly that you are unaware of the firing process. Instead, your screen appears to be a steady, continuous image, just as it does now.
Today's modern LCD technology is based on a discovery made by engineers Lehmann and Reinitzer around 120 years ago. Let's take a look at the technology in detail. In liquid crystals, the molecules are similar to long, drawn-out rods. As with crystalline structures, these molecules exhibit a strictly ordered crystal structure. The ordering of the molecules creates a directional orientation. In most LCD displays, the liquid crystals are embedded between 2 glass plates rotated by 90 degrees. This formation produces what is known as a twisted pneumatic LCD. A polarization filter is fitted onto each of the outer glass plates. These polarization filters mean that only one dispersion direction of multiple light waves emanating from a light source is allowed to pass through. The light follows the rotation of the molecules and, twisted by 90 degrees, hits the outer polarization filter. As the rotation means that the direction of the light matches that of the polarization filter, the light can also pass through this filter and brightens the outer glass plate at that point. If an electrical field is then generated between the glass plates, the special property of the liquid crystal molecule becomes fully apparent. As the molecules are dipolar, they react to the electrical field and are repelled. The rotated molecule structure is interrupted. When light then passes through the first polarization filter and follows the direction of the molecules, this hits the outer polarization filter and cannot pass through it. When a matrix is created from a number of these individual cells, it becomes possible to display graphics and images. To generate more colors, each pixel is divided into 3 subpixels. Color filters are placed over these subpixels in the colors of red, green, and blue. By triggering the subpixels differently, additive color mixing can be used to generate each color required.
Cinema Beats.
If you are planning to buy a TV, then you must be searching to know the difference between LCD and LED TV. And that is probably how you ended up here. This video will help you understand some of their differences. LCD TVs and LED TVs are technically both LCD TVs, and the screen on both the TVs is a liquid crystal display. This allows the TV to be flat and thin compared to the traditional CRT screens. A LCD display has 2 layers of glass which are polarized and joined together. The liquid crystals then pass or block the light to display the television picture. The crystals do not produce any light. The light comes from a series of lamps at the back of the screen. The difference lies in the type of light source used. A normal LCD TV uses a CFL or cathode fluorescent lamp as a light source, and the light passes through various diffusers, a polarizer, a LCD panel, and finally falls on the screen as an image. Whereas in LED TV, instead of CFL, a light-emitting diode or LED is used as a light source. Instead of using a white LED, separate LEDs for red, green and blue are used for producing a better picture quality. There are 2 types of LED backlighting. One is referred to as edge lighting, and the other is called full array lighting. With the edge lighting, the series of diodes are arranged along the outside edges of the screen. When there is power, the light is distributed across the screen. Alternatively, in full array lighting, there are several rows of diodes behind the entire surface of the screen. They provide more control over brightness and dimming, because the diodes can be turned on and off independently. Apart from this, the other differences are, a LED TV consumes less power than a LCD TV. Partly because it uses LED as a light source, which consumes less energy, and also because in a LED TV the LEDs are switched off in places where the screen needs to be dark. They're 30% more efficient than LCDs. The edge lighting in LED TV allows it to be much slimmer and gives a sleeky look to it. The local dimming in LED TV allows it to display colors with high efficiency and higher contrast ratio. You will be able to appreciate the difference better with bigger sized TVs. All these comes at a cost though. LED technology is still at its early days and will cost you approximately 30% more for the same size of the TV. Hope some of your doubts are cleared.